So let's take this first line example and attempt to do this a little bit different in preparation for our discussion of indirect memory address, where memory location is determined at runtime by using the address stored in one or two registers. Okay, so let's use a register. We have a register, so let's again use EAX or EBX. So let's say move into register EBX, something like this, right? So we know this is a addressable memory. It worked for our idea of fixed location in memory, so we can move this value into EBX, and then we can try to do this: move into memory indicated by EBX, the new value 11, right? So we just keep doing it like this. Okay, so once again, instead of this address expression that we use with respect to the memory allocation right here and the size of each integer, right, so we're just trying to update this. And this time we just say that let's use register to refer to this location. Okay, so let's save this and build it. So the first error we get that this line right here uses invalid instruction operands. So as long as we're using table, assembler knows that table is made up of double words, which are like integer sized data values. But as we switch over to the register, we have to explain to the assembler this move instruction should update 1 byte, 2 bytes, or 4 bytes. And for this, we need to say double word pointer. Okay, so this way we explain to the assembler that EBX is a register that contains the address of or is a pointer of or pointer to a double word, which is an integer in memory. Okay, so let's build this. And let's step through this code. We can just simply press F11 once again to step into, this is my debug mode, so I'll just press F11 to step into the program. Right, so we create console window and we start our debugging session. And now I can press F10 a few times and just make the updates right here. We can either use the memory window to observe what happened at these locations, but I'm assuming that everything is getting resolved as expected. One thing I would like to see is Windows using debug Windows immediate, and just show us let me just clear this from previous laboratory, and question mark address of table. Okay, so address of table is 00174000. Okay, and so here we have this physical address. And recall that if we try to look at the listing file, the table will be simply stored at the beginning of the data segment, but all elements that we add to the data segment are actually relocated by the linker. When the linker puts together the executable image, it rearranges the actual physical addresses of our data segments. So therefore, the linker assigns the real address to this, and therefore, when we make computations like this, we get the actual address in the actual memory segment. Now let's step over this instruction, right? So we just keep going, F10, and let's display our registers, Windows registers, at the bottom of this. So these are my registers, and I'm just about to update register EBX. Okay, and you should observe that the address in register EBX is not the same as this value, the actual value where the table is relocated. So this would be a big mistake, a really big mistake, to allow EBX just store a combination of or computation based on offsets in the data segment. We must tell the assembler that we need to take on account the relocation of this memory segment when the program is linked together. So of course, if I step over the next line, most likely I will end up in memory access exception, right? So if I step over the next line, F10, there it is. It's bad. Okay, so this is really, really bad because we did something wrong here. So how can we fix it? Debug, stop debugging, close this console window, and what we need to do is we need to tell the assembler that what we want is offset. Okay, so we want the offset like this into the data segment. So let's try this again. Build, press F11 to step into the program. Okay, and then we can use F10 to step over, and once again let's try the address of the table. Okay, now it's located at CB400, and we keep moving. Okay, so with this, you see that now when we use the offset, the EBX now contains correct address of our table at runtime, right? So this is, just never forget when you're trying to use whatever memory allocation you have in your segments, and that includes, by the way, the constant data segment, whichever memory segment you're using. If you try to obtain, so these are all global variables, they're available to the entire program. This is classic example of global data. This table array is sitting in the global data segment. But when you want to get its address, don't forget to use offset operator when you're using your offset expression. But you need to tell the assembler, please, also we need to make it relocatable because this data segment will be relocated somewhere in physical memory. And so the EBX gets correct address, and this time, of course, if we continue stepping through the code, everything works fine. We just, like the third time using address in the register, we updated this first element in our table. So this is our example of, I guess I'll just stop my debugging. Okay, and so this would be the example right here, the example of indirect memory access. Indirect because it's the register that knows the address. And that could be really anything, because what we did just the line before, we made some computation and loaded address into EBX, and now EBX contains what we expected to have. So indirectly, through the register, we specify memory. We also, because it's indirection, we also have to provide the data type. So EBX becomes pointer to integer, and therefore assembler knows that 11 is supposed to update all 4 bytes of this integer in memory by this instruction.